Science Beetle.
Welcome back, students. In this lesson, what I want to do is focus on the atom a little bit more. I know we kind of touched upon it briefly when we talked about elements and atoms in the previous lesson, but I want to give you a little bit of a background as to how we got to the atom. And we already know that atoms are the smallest units that compose elements. What we don't know is, or at least what we haven't discussed yet, is how it came to get its name, the atom, how it came to get its name. Well, it all began back in approximately 400 BC. There was a gentleman by the name of Democritus, who essentially was exploring the concept. He was exploring particles of matter, and what he said was that matter was composed of this thing called the atom. And that was the prevailing view back in 400 BC. And he did all kinds of thought, keep in mind that he's a philosopher, and so he was thinking about this very deeply. And then after that, the philosophers that came after him, for example, one of the most notable is Aristotle. Aristotle then kind of debunked that, and he really didn't believe in the atom. So let me just write here, Democritus believed in the atom, and or at least that's what he called it. But Aristotle then, as you keep going down this line, Aristotle did not believe in the atom. In fact, what Aristotle was saying was that essentially all we had was the elements. That was it. And it was not until even further down, until about approximately the 1700s. In fact, it's a long time, but down here about the 1700s, even then, the concept was still that the element was the smallest part, or the smallest particle, or the smallest component of what these things were. The element couldn't be broken down any further. But it was not until the work of another gentleman, which was called Dalton. Dalton in 1808, and I'm just going to write him here, Dalton. Dalton then reestablished the work that kind of confirmed what Democritus had done over 1,000 years prior. In fact, almost 2,000 years prior. But the work came from Dalton, where he did some experiments that kind of explained and said, yes, actually elements are made up of smaller things, and those smaller things are called atoms. Essentially what had happened was from the 1700s on, until Dalton did his work, to about 1808, and this is where we have Dalton over here. During this time, between 1700 and 1808, there were much research that was being done on elements and in chemistry. And there were three main laws that came into play. And these laws essentially said the following things. The first law was the law of conservation of matter. And essentially, this particular law said that mass is neither created nor destroyed. The second law that came from these experiments was the law of definite proportions. And basically what this law said was that any compound that contains the same number of elements or has the same elements in it is going to have the same proportion of those elements regardless of the mass or the sample. So you can have a very big amount and it's still going to contain the same proportion of elements, or you can have a very tiny small amount that could essentially be the size of a speck of salt, and it would still have the same proportions of elements in that particular sample. And that's all the law of definite proportions is saying. The last law is the law of multiple proportions. And essentially this particular law says that if two or more different element compounds are composed together, they compose of the same two elements that you have. The ratio between the two elements, in other words, the mass of the first element and the mass of the second element are always going to be in the same ratio. And they're always going to be whole numbers. And so the law of multiple proportions is generally talking about the ratios between the elements between the first element and the second element. So up until 1808, right before then, the general thought was that elements were essentially the bottom. That was the smallest division that any kind of compound could get. But with Dalton's work, what he did was that he put forth several ideas. One of the first ideas was that as matter is composed of very small particles called atoms. The second thing that he said was that atoms of a given element are identical in size, mass, and in other properties. And essentially, I'm going to kind of simplify this, but essentially he said the atoms of the same element are identical. The other thing he said was that atoms of different elements are different. Dalton also said that atoms cannot be subdivided, created, or destroyed. Essentially, the atom was the smallest piece, the smallest component. And then the last thing that Dalton said, and I'll go ahead and write this here at the very bottom, see if I can, was that atoms of different elements essentially combine to form compounds. And so when he came along and did this experiment in 1808, or the years after that time, essentially Dalton had come to essentially kind of reestablish the smallest particle that is available in matter to be the atom. And prior to that, many of the scientists had believed for a very long time that the smallest unit of matter was an element. And he kind of showed and proved that actually that is not true. And what does the atom look like? And so let's talk a little